Oxidation reduction reactions. This reaction, also shortened for redox, occurs when electrons transfer from one reactant to another. The rusting of iron, the bleaching of hair, the production of electricity in batteries. Those are all examples of oxidation reactions, oxidation reduction reactions. We know that metals tend to lose electrons to nonmetals. That's when oxidation occurs. Oxidation is losing. When nonmetals usually gain from metals, reduction is occurring. Reduction is gaining. Identifying whether or not a reaction between a metal and a nonmetal is redox can be found by assigning something called oxidation states. So in general, atoms of metals lose and nonmetals gain. So if we look at this reaction right here, we have copper and oxygen forming copper 2 oxide. So another little practice of naming compounds. This is a transition metal. This is a nonmetal. We know oxygen is -2, so copper had to be +2. So this is copper 2 oxide. Just to continually always practice nomenclature. So in order to determine whether or not this reaction is a redox, we have to assign oxidation states. So assigning oxidation states, I'm going to write the equation up here. We had copper plus O2 gas made copper oxide, solid. And we have to make sure it's balanced, so we need a 2 here. And then a 2 here. Okay, so the oxidation state of an atom in a free element is 0. Free element means pure form. Pure form, natural state. So like all of the diatomics, chlorine, hydrogen, fluorine, bromine, oxygen, nitrogen, etc., those are all the pure form. The metals all exist as solids. When you have an element that exists in its natural state, the oxidation state is 0. So for example, copper, solid here, that's its neutral free element form, so that oxidation state is 0. Oxygen gas, that exists as O2 gas, pure form, so that oxidation state is also 0. The oxidation state of a monoatomic ion is equal to its charge. So what this means is if I have copper +2, for example, the oxidation state would be +2. 5Cl minus, the oxidation state would be -1. So when you have a monoatomic ion, a single element in its ionic form, the oxidation state will equal its charge. The sum of the oxidation states of all atoms in a neutral molecule or formula has to be 0. So that goes with our example. CuO, copper 2 oxide, that's a neutral element. It doesn't have a charge by it. So the sum of the oxidation state of copper and the oxidation state of oxygen has to be 0. So copper plus oxygen, I'm going to write O2, must be 0. Alrighty, well, I know that in order to form copper 2 oxide, it's an ionic compound, there was the charges involved. Oxygen is always -2, and I know, therefore, copper had to be +2 to make 0. An ion is equal to the charge of the ion. So, for example, here, if we have SO42 minus, the sum of the oxidation state of sulfur and oxygen has to be -2. So sulfur plus 4 oxygens has to be -2. In compounds, metals have positive oxidation states. Nonmetals are assigned the oxidation state according to their charge. Now, oxygen is always -2. So if you have a nonmetal ionic compound that has multiple nonmetals and one of them is oxygen, you assign oxygen to have -2 and you solve for the other one. So here you know oxygen's -2 and there's 4 of them. So that gives you -8. Sulfur plus -8 must be -2, so the oxidation state for sulfur is +6. Now, we assigned, back to our example, +2 for copper, -2 for oxygen. So we have to determine, is this a reduction oxidation reaction? So copper went from 0 to positive 2. It became more positive, less negative, lost electrons, so it oxidized. Oxygen went from 0 to negative 2. It gained electrons, became more negative, so it reduced. So when assigning whether a reaction is redox, you have to always assign oxidation states based off of the oxidation state rules. Determine what lost and what gained, and then if nothing changed, you do not have redox. If something did, you might. No, you have to have oxidation and reduction in order to have a redox reaction. One more part to this is looking at the agent. So if we go back to the equation that we had, copper plus O2 makes copper 2 oxide. We said copper was oxidizing and oxygen was reducing. So that means on the reactant side, these two reactants helped each other out. So since copper was being oxidized, it lost the electrons, and oxygen reduced, it gained. Copper is the reducing agent. Whoops. And since oxygen was reduced, oxygen is the oxidizing agent. It's always opposite because they have to help each other. These electron transfers don't just come out of nowhere. So since copper is oxidized, it was the reducing agent. And since oxygen is reduced, it was the oxidizing agent. And that's it.